So today there is a change and we are going to start some science lesson also. So let's do some tricky question in science from matter and magnetism. Let's start with these questions I have picked up from global Olympiads, and let's see how this actually is from grade 4. Literally saying the questions are from grade 4, and let's see how the questions are very tricky compared to if you see the Indian or any other exam. So let's proceed with. So the question states, the diagram below shows a pump. So you can see a pump that has been attached to a, so this is a jar. This has been attached to the 300 centimeter cube of jar. That means your volume is given. So volume of the jar is given, and that volume is given as 1300 centimeter cube. What else is given? So it is attached to a plunger. So there is a plunger, right? So the plunger is there. That means it can compress the pump. So all the 50 centimeter cube of air and the water will be inside the plunger. Okay. So we have the volume given as 1300 centimeter cube. Now what is the question? When lazy pushed plunger completely, so it is pushing the plunger completely like this. That means all the air and water in the pump were pushed into the jar. Now the question asked to you is, what will be the new volume of water? So definitely what you have to think in respect of matter and in respect of science, that what can be compressed and what cannot be compressed. Now you see water is a liquid and liquid cannot be compressed. So the volume of the jar will increase, and we will write like that since liquid cannot be compressed, so the new volume of water will increase to 750 centimeter cube. Now the volume of water will be something like here, and the new volume of water will be, this is 50 centimeter cube. Now tell me another point. So they are asking, what will be the new volume of air? So will it be 600 centimeter cube, or you are thinking 650 centimeter cube? Tell me, what will be the new volume of air? Because now you think this air was how much? 50 centimeter cube. But you remember, air can be compressed. Air can be compressed. So will the volume of air will increase from 600 to 650, or it will remain the same, or it will decrease? To be very frank, the air volume will decrease. Why? Because now the new volume of the tank with water is 750 centimeter cube. This is now the new volume of water. This is 750 centimeter cube. So only the remaining space will be occupied by air. So how much it will be? 550 centimeter cube. So we must write air can be compressed and water cannot be compressed. So the remaining area only will be filled with water. So the new volume of air will be 550 centimeter cube. This was the question asked in Banda Global Science paper. Let's do number 2. Now, Leo prepared 2 identical beakers as shown below. He tied a ball and a stone with a string and placed them into beaker X and Y respectively. So first point to be noted here is that, first point, they are identical beakers. Okay. Next, he tied a ball. So this is a ball and this is a stone. So with a string, so they have tied it with the string and placed them into the beaker. Next what has happened? Leo then poured water into the ball. So they have placed water into the ball. Leo then poured water into the beaker with the ball, and until they have the same water level. So let me think, they have filled the water to the brim and it is like that. Okay. So the question here is asked, the question here, what they have asked, let me tell you. So in the next slide, we'll see. So this is the question. What can Leo do if he wants to find out whether the ball or the stone has a larger volume? So first thing that you have to realize that we have filled the water to the same level. The water is having up to the same level. Okay. And now he is not allowed to use any apparatus or equipment or pour into an water to the beaker. So you have to say how he can measure the volume of ball or stone and how he can tell which one is having the beaker, which one is having the larger volume, ball or stone. Okay. So the concept here is very clear. Take out the ball and the stone very, very smoothly and gently. Okay, so that the water does not splash. You cannot splash the water. If the water becomes splash, then the correct volume you will not get. So if you pull it out, suppose the stone is out and ball is out and the stone is out. So what do you think? The volume of water will decrease. The level of means volume, no, level of water will decrease. Level of water will decrease in both containers. And since the containers are identical, suppose now in this case, after taking out, so you have two containers, and after taking out, suppose this is the level of water here, suppose this is H, and this is the level of water here, suppose you can see where the volume, where the level is higher. So whichever is, suppose here, suppose this is this and this is this. So decrease in the level is where? Here there is more decrease, no? That means ball has more volume, because what is volume? Volume is the space occupied by an object. Space occupied by object. That means if the decrease is less, that means this was occupying more space. So ball was occupying more space than stone. That is the logic. Then you have to concentrate on that they are going to ask you. Okay, let's try the next question. This is pure in magnetism. So it says if M is the north pole of the magnet, this is the north pole of the magnet. And then they say, find what would be the poles of O and S. Okay, so see here when you do magnetism, so we know the rules of magnetism that like poles repel each other and unlike poles attract each other. So if you know this concept, then we can do this question very efficiently. See, so what is there? So you can see north and south pole together, because a magnet is always made up of north and south. North and south. Always a magnet is north and south combination. So if this is attracted, N and U are attracted, this must be north. Similarly, this will be south, because north and south. And now, if you see, this is north, then this will be south. This will be north then. Now, if this is south, then this will be north. This will be south. This will be south. This will be north. So the poles of O will be north and S will be north. Got it? Very clearly got it. So that was a concept being tested, that whether you have understand that like poles are repelling it and unlike poles are attracting. So that was the concept being tested in this question. Now, yet another very, very interesting question. So a person, Ricky, accidentally dropped an iron nail into a container of oil. So this was the container and this was having oil. and this is the iron nail. Okay, this is the iron nail which he dropped off accidentally. This is the oil, this is the container. Now, what is happening? Listen. So without dirtying his hands, he tried to move the iron nail from the base to its brim. Brim means this top part. So if he move this bar, so since this is a magnetic material, I'll come to the point, what are magnetic materials? So if this is a magnetic material and we know that iron is a magnetic material, so it should come forward. Forward means it should come up. But here they are saying along the side of the, give two possible reasons why did the iron nail does not move. Why did the iron nail does not move when the bar magnet was moved towards it? Why did the iron nail does not move? You can see, because you can say that because while is putting barrier, you can think. No, absolutely wrong. While any fluid does not stand as a barrier in the magnetic field. Okay, remember it. So whether the oil you take, any fluid you take water, you take juice, you take any viscous liquid, that doesn't matter because of this fluid concept. Viscosity, it doesn't matter. Okay, so the magnetism does not get affected by taking any type of fluid. So now you have to think, what are magnetic materials? What are magnetic materials? So they are still iron, nickel, and cobalt. You can also remember like superhuman is not cute. So that is a mnemonic to remember this. What are magnetic materials? So magnetic materials are attracted towards the magnet. That is the definition of magnetic materials. So you know now iron is magnetic. We know now iron is magnetic because we have listened now that iron is coming under magnetic material. So instead being magnetic, why it is not attracted? That means we have to think about the container. Now listen. So if the container is magnetic, the container is, because they have not said it is magnetic or not. If the container is magnetic, then iron nail will not get attracted. Will not get attracted. So definitely if it is made up of plastic, so plastic is non-magnetic, then it could have got attracted. So we must say the container is magnetic in nature, so that the iron nail was not attracted. So it just reversed. You might be thinking that this container should be magnetic, but it should be non-magnetic. Okay. So because if the container will be magnetic, the container will move, not the iron nail. Okay. Okay. Another point could be, another important point could be, the magnet should not, means magnet may not be so strong so that the magnetic field will not be so strong to make the iron nail move. If it is not in the side of container, another reason could be the strength of the magnet. So strength of magnet may not be very powerful. Okay. So let's go to the next question. Gabriel was trying to make a temporary magnet with his iron nail. So in which condition the temporary magnet will be formed? Okay. So see here carefully. So this is a battery, or we say a dry cell. Okay. And then we have the iron nail, that is a magnetic material. And then we have coils of iron around it. So using electricity, it is possible to make it a temporary magnet, not for lifetime, but yes, for temporary magnetism, we can build in this iron nail. So possible. Now here, what do you think this magnet is doing here? Nothing. A magnet cannot convert it into through a circuit, when a magnet is passed, nothing, it will have no effect. So here it cannot turn. Now you see this position. So this is the position when we have taken an iron nail and we are moving it like this. We are moving it like this, like this, like this, like this, like this, like this. So no magnetism. For magnet, we have to move like this, north to north or south to south. Okay, it should be moved in one direction. Okay, it should not move in two direction. Otherwise, magnetism will not happen. So this no, this no, this one. What do you think? Yes, because it is moving like this. Not pull. Yes, 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 like this. We are rubbing like this. So this is possible. So this and this is possible, and this is not possible to make magnetism. So these are the ways of converting magnetic material into a temporary magnet. Okay, so that was for today. So we'll come with some more interesting questions. Hope you enjoyed. Take care. Bye bye.